Welcome to the DOE stakeholder training. This is just a quick overview, an introduction, if you will. I suppose I should introduce myself. My name is Alex Buck. Welcome to the program, so to speak. All right, so I'm just going to quickly run over what's going to be covered, go over some important definitions and a couple other little logistically things. So, course overview. We're going to start out in the first unit, just do an overview of what design of experiments are, right? What's a DOE? What are the advantages? What's the experimental process? Simple enough. The second unit, we're going to go over your role as a stakeholder. Where in the process are you going to be involved? And what is going to be needed of you? Like, what is it that you can contribute to the overall experimental design process? And then we'll wrap up the last unit of getting the results. So the experiment's in run. What are you going to get out of the process? How do you interpret the results? And then really what's next? What's after that? What happens after that experiment is run? All right, let's jump into important definitions. Ew. The first is response. This is the measurable output of your system. We also sometimes call it the Y, as in Y equals some function of X's. Now, what a response is in one set of experiments might turn to a factor in another one. And so the next thing we're going to talk about is factors or X's, right? So you might have a force coming out of a subsystem, some motor with some gear train mechanism, and it produces a force. And you care about that force, so you're running experiments to measure that force and doing different gearing profiles or whatever it happens to be to measure that output force, right? But then you might end up using that output force, that response in that set of experiments, as a factor in some fluid flow mechanics, right? Because whatever that force is, it's pushing on a tube that, maybe it's a peristaltic pump or something that is pushing a fluid through a tube. And so that force might end up being a factor for some other experiment, right? So factors are the knobs we can turn with the design that impacts the response, that output. We also call that X's and possibly control factors. Now, control factors are those ones that you specifically have control over in your design. There's another set of factors that are called noise factors. These are the ones outside the control of the design. It's user-to-user variation, it's environmental conditions, it's manufacturing process variation. Anything that's outside, any factor that's outside the control of the design, that's a noise factor, including noise. Factor interactions. Well, factor interactions are when one factor, one X, impacts how another factor, some other X, impacts Y. Right? If I were to throw a ball sort of moderately hard and I threw it straight up, how far would it travel away from me? Nowhere. It would come right back down. If I threw it at a 45-degree angle, how far would it travel? I don't know, 20 feet, 10 feet, whatever. Now, if I threw it really, really hard straight up in the air, it still wouldn't go anywhere. It'd still just come right down. If I threw it really, really hard at 45-degree angle, maybe it doubles the distance from when I threw it a little bit less, right? So based on what angle, that's one factor, how hard I throw will impact its response differently, right? It doesn't matter how hard I throw it. If I'm throwing it straight up, it's just going to travel nowhere. It's coming right back here. If I do it at an angle, it's very much impacted by how hard I throw it, right? So angle and how hard I throw it are factors that impact each other in how they impact the response, in this case, the distance that it went, right? So that's factor interactions. Now, here are some approaches to experimentation. There are a couple of different categories that we'll go over. One is active versus passive experimentation, right? Active, you control the factors, you purposely change them, and generally speaking, if you're good at it, it's very good for statistical analysis. Hopefully you're not just doing active, control factors and making horrible, horrible choices. Passive experimentation. is when the data for the X's and the Y's are just taken without controlling the values, right? So if you happen to be taking temperature data of a clean room and you're testing, you want to do some tests to see if that impacts the quality of the product going out the door, well, you might not be raising and lowering the temperature, but you might be measuring just natural variation that happens and then try to make a relationship with that with, product quality, right? Okay, so say you're doing active experimentation, let's break that up into a few different approaches. The first is trial and error, which may or may not be good for statistical analysis. Typically not, but it could be. Way inefficient, just super inefficient, and just horrible that way. It does require some luck that you land on the right combination of things. It's really just sort of like quagmire inducing for your project. So if your project is sort of just stuck in the mud, there's a good chance that there's a lot of trial and error going on. Next is one factor at a time testing. It's certainly better than trial and error. It's intuitive, but it's also inefficient. So you might be moving forward, right, in a way that you're not with trial and error, but you're not flying ahead. You're not gaining a lot of knowledge very quickly. The other drawback is that it can't estimate interactions like we were just talking about, right? If you're separating out those experiments, even if you ran all the combinations, it's, let's just say, statistically dubious to combine different experiments together that way, unless you intentionally build a structure to do so, which is, there's some very advanced experimental design techniques that allow you to do that. But otherwise, it's just not a great thing to just be throwing one factor at a time tests together, and therefore they cannot estimate any potential interactions that you might have amongst your factors. Then last but not least is experimental design, aka design of experiments, or DOEs. And the following videos, we're going to dig into DOEs a bit more and why are they so advantageous, because they just sort of are. And comparing these three different buckets, trial and error, one factor at a time, and design of experiments, they're really just not even close. They're significant steps up, but then even exponentially so. Experimental design is just so far beyond one factor at a time and trial and error, and so many different options that it's sort of a misnomer to say it's sort of one group of thing. But if we're just talking about how much control and thought you put into an experiment, trial and error is none, effectively. One factor is like very simplistic approach, and then experimental design is everything else. Just this massive, just bevy of awesome options that can really allow you to gain a ton of knowledge on your products. So there you go. That's what we're going to cover in this course. Those are some definitions, and let's get to it.